Welcome to the hands-on part of our OpenStudio journey. In this video, we'll start modeling from scratch and build a complete, simple energy model step by step. We'll draw a 10 meters by 5 meters single-story building, add windows and a door, assign a thermal zone, space type, and construction set, and finally generate a full 3D model ready for simulation. By the end, you'll have a working OpenStudio model and the confidence to create your own. Let's begin. We're going to kick things off by building a simple model with just one space and a single thermal zone. Take a look at the geometry shown here. For this exercise, we'll focus on defining the envelope geometry and constructions for this basic building. This setup lets us simulate how the envelope responds to weather conditions without any conditioning. Later on, we'll add internal heat gains tied to how the space is used, and we'll revisit this model again to include an HVAC system for space conditioning. Let's dive into your OpenStudio journey with the first step, setting up the location and weather file for your model. We recommend grabbing a weather file for your own city to make it personal. You can find free EPW weather files here. Just download the data for a location that interests you. Once you've got those files ready, it's time to create your first OpenStudio model. Find the OpenStudio application on your computer and give it a click to launch it. As the program kicks off, you'll see a startup dialog pop up while OpenStudio creates a fresh, empty model behind the scenes. After a short wait, that dialog will fade away, and you'll be greeted by the main OpenStudio application window, your new workspace. Just like with any digital project, it's smart to save your work regularly and back it up along the way. This way, if you hit a snag, you can roll back to your last save instead of starting from scratch. Kick things off right by heading to the File menu and choosing Save. A dialog will pop up, letting you pick a working directory and name your model. Saving creates an OSM, OpenStudio model file. Think of this as the main file you'd share with others along with a matching directory. That directory will eventually hold supporting files, simulation results, and more. Let's get saving and start building. When you first launch the OpenStudio application, it opens right to the Site tab. This is where you'll set up all the key location and weather details for your model. OpenStudio uses this tab to connect your project to real-world conditions, which is crucial for accurate simulations. Now, look for the Import Weather File button and click it to select the EPW file you downloaded earlier. These EPW files, packed with hourly weather data, are the backbone of your energy analysis, and OpenStudio will automatically pull in important details like latitude, longitude, and elevation for your chosen location. Once you've attached the file, save your model again by hitting Save in the File menu. Good habits start early. After saving, peek into your model directory, and you'll see a new file subdirectory with a copy of your EPW file. This organization helps OpenStudio keep everything tidy and accessible as you build your project. With your weather data locked in, you're ready to move forward. Let's keep the momentum going. Let's move to the next step, defining properties for the materials in your building. Head over to the Constructions tab in the OpenStudio application. This is where you'll shape how your building handles heat and energy. Inside this tab, you'll find three handy sub-tabs: Construction Sets, Constructions, and Materials. Since we're starting with the basics, click on the Materials sub-tab to get going. On the left side of the Materials sub-tab, you'll notice a neat breakdown of material object types. Look for categories like Materials, No-Mass Materials, and others. These help you pick the right type for your project, whether it's a solid wall or something lighter. OpenStudio uses these definitions to calculate heat transfer accurately, so let's dive in and set them up. Let's explore the different material types you can use, which align closely with what EnergyPlus supports. If you're curious about the nitty-gritty details, check out the EnergyPlus input and output reference and engineering guides for a deep dive. For now, we're starting simple by creating a new material of the no-mass materials type, perfect for lightweight layers like insulation. Click on the No Mass Materials label in the Materials sub-tab, then hit the plus button to add a new object. Let's name it My Insulation to keep it personal. Now, set the roughness to rough and assign a thermal resistance of 2.29. Now, repeat this process for other material categories using the properties provided in these tables. Follow along carefully, and you'll have your materials set up in no time. By now, we've created a few material objects manually, which has given us a solid grasp of how materials work in OpenStudio and its partner, EnergyPlus. But let's be honest, manually setting up materials can be time-consuming and easy to mess up if you're doing it repeatedly. So let's make life easier by tapping into OpenStudio's powerful built-in libraries, a fantastic resource packed with ready-to-use energy modeling data like materials, constructions, and space types. Here's how it works. The OpenStudio application lets you pull data from existing OpenStudio models, or OSM, by loading them as a library. This means you can borrow components like space types, constructions, or materials from a library and add them to your current project. To get started, go to the File menu and select Load Library. This opens a dialog where you can browse for library files to use in your model. Let's talk about another fantastic resource for material data beyond existing OpenStudio models. The BCL is an online treasure trove of energy modeling data that's designed to work seamlessly with OpenStudio. Think of it as a one-stop shop for pre-built components like materials, constructions, and more, ready to enhance your models. You can explore the BCL through its web interface, which is great for browsing. But the real magic happens right inside the OpenStudio application. Just head to the Components and Measures menu, and you'll find direct access to the BCL's library. This integration makes it super easy to pull in high-quality, standardized material data without leaving your workflow. For now, let's focus on materials. Click on the Material category, then select the Opaque subcategory to view a list of available opaque materials. Browse through the options, pick one or more materials that suit your model, and hit the button at the bottom of the window to download them. Just like that, those materials are added to your current OpenStudio model. Now that we've added materials to our model, it's time to combine them to build constructions using the Constructions sub-tab. In the OpenStudio application, navigate to the Constructions sub-tab, select the Constructions object type, and click the plus button to create a new construction object. On the right-hand pane, you can explore all the materials currently loaded in your working model or available in your library. Just click on either My Model or Library to browse the materials. To add a material to your construction, simply drag it from the list to the Drag from Library drop zone in the construction editor. It's that easy. If you need to remove a material, just click the cross button next to it in the editor. Here's a key tip. In OpenStudio, construction layers are ordered from the exterior layer at the top of the list to the interior layer, closest to the space at the bottom. So, as you build your construction, make sure the layers are arranged in the correct order to reflect the real-world assembly. Libraries in OpenStudio aren't just for materials, they can also include complete constructions. In the OpenStudio application, head to the Library section and select the Constructions category to see any pre-built constructions imported from an OpenStudio model file or the Building Component library. Just like with materials, you can drag and drop these ready-made constructions directly into your working model. The best part? This automatically brings along all the associated materials from the library, saving you effort and reducing the chance of mistakes. Now that you're familiar with building constructions, let's use the Construction sub-tab to create the construction objects listed in the table provided on screen. Take your time and feel free to pause the video if you need a moment to work through the steps. We're ready to take our constructions to the next level by grouping them into a construction set that can be applied across the entire building. Let's do this step by step. In the OpenStudio application, navigate to the Construction sub-tab and click the plus button to create a new construction set. Name it My Construction Set to keep things organized. Now head to the My Model section, where you'll see all the constructions you've created. As shown here, drag the appropriate constructions from My Model into the corresponding slots in the construction set editor. These slots are labeled for different surface and subsurface types like walls, roofs, or windows, so make sure each construction lands in the right spot. This construction set will act like a blueprint, streamlining how you apply constructions throughout your model. The final step is to apply our construction set to the entire building so that every wall, floor, roof, and window automatically uses the right assemblies. Head over to the Building tab. You'll find it in the main vertical tabs on the left. Look for the default construction set slot near the top. Simply select My Construction Set from your model and drag it straight into that slot, just like we're doing on screen right now. That's it! With one drag and drop, the whole building now knows exactly which constructions to use by default. Just like materials and individual constructions, you can also pull entire construction sets directly from a library or the Building Component Library, BCL. Many modelers start new projects by dragging in a ready-made construction set that matches their climate zone or building code, like ASHRAE 90.1, Title 24, etc. It instantly sets up all the typical walls, roofs, floors, and windows, saving hours of work. That said, we walked through building one from scratch today because it's really important to understand what's inside these sets. Once you know how they're put together, you can confidently evaluate any pre-built set, tweak layers, upgrade insulation, or customize glazing to perfectly fit your project's goals. With weather files and our construction set in place, it's finally time for the fun part, creating the building geometry. Head over to the Geometry tab on the left-hand sidebar. This opens OpenStudio's powerful geometry editor and previewer. When you first switch to the Preview sub-tab, you'll see an empty window. That's normal because we haven't drawn anything yet. Now click on the Editor's sub-tab right next to it. Here you'll find OpenStudio's built-in 2D floor plan editor, along with some welcome text and a big new button. Go ahead and click that new button. A quick start dialog will pop up, just like the one shown on screen right now. Choose the new option to start a fresh floor plan on a clean grid. Now that we're inside the floor plan editor, let me quickly walk you through the key sections so you know exactly where everything is and what it does. Here's what you're looking at on screen. At the very top, you have the Drawing Editor subtabs. These let you switch between drawing the actual floor plan, assigning construction sets, space types, and thermal zones to different areas, and adding windows, doors, and other subsurfaces directly onto walls. Right below that is the Drawing Toolbar, Rectangle tool for quick rectangular spaces, Polygon tool for any custom shape, Floor to Floor Copy tool, a real-time saver for multi-story buildings, Rectangular Eraser tool, and the option to import a background image, perfect when you want to trace over an architectural floor plan. Next, the grid settings, which turn snapping on or off, and adjust the grid size so your lines line up perfectly. On the left side, the story pane lets you add new stories, rename them, change floor-to-floor heights, or multiply a story upward. Still on the left, the space pane shows all the spaces on the current story. From here, you can add, delete, or edit individual spaces, and the drop-down at the top even lets you work with shading surfaces or background images. Finally, at the top right, the model integration buttons. These are the magic ones. When you're happy with your 2D drawing, just hit Preview OSM, and OpenStudio instantly turns your floor plan into a full 3D model with proper spaces, surfaces, and thermal zones. For this simple model, we're going to use the built-in Grid Snap feature. It's a lifesaver when you want everything to line up perfectly. Here's what to do. Look at the upper right-hand corner. Make sure the grid checkbox is ticked. When it's on, everything you draw will automatically snap to the grid. Right next to the checkbox, set the grid spacing to 1 meter, just type 1 and hit enter. Now zoom in a bit, roll your mouse wheel or use your trackpad pinch gesture. Perfect. With a 1 meter grid and snapping turned on, every click you make will land exactly where it should. No crooked walls, no tiny gaps. Great! As soon as we created the new floor plan, OpenStudio was kind enough to give us a head start. It automatically created Story 1 and a single space called Space 11. That's our starting canvas. Everything we draw right now will belong to this space and this story. A couple of quick things to know before we start drawing. If you make a mistake, no problem. Just hit the Undo button or Ctrl-Z in the upper left corner. There's also a Redo button right next to it. When you draw adjacent rectangles, they automatically merge into the current selected space. Super handy for creating L-shapes or any irregular floor plan. The Eraser tool lets you subtract rectangular areas if you need to carve out corridors or courtyards later. The height of our space isn't set here on the plan. It's controlled by the story it belongs to. Okay, let's jump right back into our simple model. Quick recap of where we are. We're in the floor plan editor. Grid Snap is on with 1 meter spacing. We have Story 1 and Space 11 already created. Undo and Rito are ready in the top left corner. The story pane is open on the left so we can adjust heights whenever we need to. Now it's time to draw. In the next step, we'll grab the rectangle tool and create our first 10 meters by 5 meters footprint. Speaking of stories, let's open the story pane so you can see where everything lives. Look on the left side of the editor and click the little arrow button to open it up. You'll see story 1 listed there. That's the one we're working on right now. Later, we can add more stories, or duplicate this one upward, but for this simple model, we'll just set the height to 2.7 meters. Now, let's assign a thermal zone to our space. This is a critical step because EnergyPlus simulates energy at the thermal zone level, not individual spaces. Here's how to do it. Near the top of the floor plan editor, click the Assignment sub-tab. It's right next to the Drawing tab. This is your command center for assigning construction sets, space types, thermal zones, and more to any part of your model. By default, the Assignment choice menu on the left shows thermal zones. And that's what we want. Right now, our model has no thermal zones, so we need to create one. Click the plus button immediately to the right of the menu. This adds thermal zone 1. Now simply click on space 1 in the drawing area. Watch it highlight and instantly link to thermal zone 1. Done. Your space now belongs to a thermal zone, and EnergyPlus will treat it as a single controlled volume for heating, cooling, and airflow. Pro tip: in real projects, you might group multiple spaces, like all offices on a floor, into one thermal zone, if they share the same thermostat and HVAC settings. But for this simple model, one space and one zone is perfect. We're in the final stretch of our simple model. Time to add 2 windows using the Components sub-tab. Let's do this step by step. At the top of the floor plan editor, click the Components sub-tab. It's the third tab after Drawing and Assignments. Notice how the Spaces pane on the left now shows window definitions instead of spaces. This is where we create reusable window templates. Click the plus button to add a new window definition. A new entry appears. Click the expand arrow next to it to open the details. Name it Window 1 and set width 2 meters, height 2 meters, and sill height 0.4 meter. This is the distance from the floor to the bottom of the window. Now hover your mouse over the perimeter walls. You'll see green preview highlights showing valid window placement zones. OpenStudio won't let you place windows in corners or overlapping doors. Click once on the south-facing wall to place the first window. Click again on the same south wall a bit to the side to place the second window. That's it! 2 windows are now perfectly placed, and because we used a window definition, both are identical and automatically linked to the correct construction from our construction set. With the geometry now fully defined for our initial model, click Merge with Current OSM to convert your 2D floor plan into a complete 3D model ready for use in OpenStudio. Click Preview OSM to inspect the result. It should resemble the example shown here. Let's add an exterior door to the east wall, just like we did with windows, but this time we'll use a door definition. Here's how. Stay in the Components sub-tab. We're already there from adding windows. In the Spaces pane and on the left, scroll down, click the drop-down at the top, and select Door. Click the plus button to create a new door definition. Click the expand arrow to open its properties. Name it Door 1. Set width 1 meter, height 2.5 meters. Now, hover your mouse over the east-facing wall. You'll see green placement zones appear. Click once on the east wall, about 1 meter from the corner. Use the 1 meter grid snap. Done. You now have a standard 1 meter by 2.5 meters exterior door, correctly placed and automatically using the pre-made exterior door construction we pulled from the library earlier. The model should look like this image. If the model appears incorrect or incomplete, return to the floor plan editor, adjust as needed, and remerge until the 3D representation meets your expectations.